Hello students, welcome to my channel Parina Jain Tutorials. So this is our last topic of our chapter acid, bases and salts. In this chapter you will be learning about salts. So let's start. So from where the salt is obtained? The salt is obtained from acids and bases. This is what we have learned, that acid and base react together to form salt and water. For example, NaCl is obtained from a base NaOH and an acid HCl. So Na is a cation, which is NaCl. In the NaCl formula, the Na is the cation. This Na is obtained from a base, the cation, and the anion is obtained from the acid. This is how we will categorize. So in this another formula, like calcium carbonate, this is a cation. This cation is obtained from a base, calcium hydroxide, and this carbonate is obtained from an acid. So carbonate will be produced from the carbonic acid, H2CO3. This is a carbonic acid. So it's very easy to determine. What we need to do is that this is obtained from a base. So what we are going to do? Just we are going to put the OH after it, and this NO3 is obtained from the acid. So what we are going to do is that we are just going to put H before NO3. Okay, and after this you will crisscross the valencies. The valency of potassium is 1, OH is also 1, so formula will be KOH, and the valency of hydrogen and nitrate both is 1, that is why the formula will remain HNO3. But if the valency is 2, for example in this case, then the formula will be CaOH whole twice. And in carbonate also the valency is 2, then the formula will be H2CO3. Now the next example is of aluminium sulfate. This is also another salt. So aluminium is obtained from the aluminium hydroxide, and sulfate will be obtained from the sulfuric acid. Now we have learned this. But do you know that all the salts are not neutral in nature? There are some salts which are slightly acidic or slightly basic in nature. So how we come to know about this? If strong acid and weak base mix together, the salt formed will be slightly acidic in nature. Its pH will be slightly below 7. And if the acid is weak but base is strong, then the salt will be basic in nature. Its pH will be slightly above 7. The pH could be like 7.5, 7.3, 7.8, like this. But it will remain salt. It will not become base. It will remain salt. Now why this happens? Strong acid means it has a more concentration of H plus ion. And weak base means it has a very less concentration of OH minus ions. So when OH minus ion concentration is less and H plus ion concentration is more, that means the OH ions are not able to neutralize all the H plus ions. Some H plus ions will remain. That is why the salt which has become, that will be acidic in nature. We will not call this salt to be acidic. Means it will not become acid. It will remain salt, but the salt will be slightly acidic in nature. Similarly, if the acid will be weak, means it is having less amount of H plus ions, and the base will be strong, means it produces a lot of OH minus ions. Okay, we have learned that weak acid and strong acid means that strong acid means which ionize into, all the compound have ionized into ions. All the molecules liberate H plus ions. So that means a lot of H plus ions have been produced. And weak acid means some of the compound has remained still in the molecular form, and some of the molecules has turned into ions. So we have less amount of OH minus ions. That is why the OH minus ions which have produced, which is in less amount, they are not able to neutralize all the H plus ions. So this is how the acidic and basic nature is been determined. If strong acid and strong base react together, then the neutral salt will be formed. And similarly, if weak acid and weak base react together, then also the neutral salt will be produced. Now let's understand it one more times with an example. Strong acid means hydrochloric acid, for example, we have taken, and weak base means ammonium hydroxide we have taken. Now the same rule, this ammonium as cation and this chloride as anion will form a bond together to make ammonium chloride. This will be our salt, but this salt will be acidic salt. Why? Because this is a strong acid, it will produce lot of H plus ions, and this is a weak base, so it will produce less amount of OH minus ions. The amount of H plus ion will be greater than OH minus ions. So that is why this OH minus ion is not able to neutralize all the H plus ions. So that is why the salt will become slightly acidic in nature. Similarly, if we are having acetic acid as a weak acid and calcium hydroxide as a strong base. Now again, this calcium as cation will react with the anion of the acid. So anion here is this acetate. This acetate is anion. This H will be removed. So this acetate will combine with the calcium. Now valency of calcium is 2, but acetate is 1. So the formula will be calcium acetate and CH3COO whole twice and Ca. This will be our calcium acetate. But this salt will be slightly basic in nature because our base was strong and acid was weak. That is why this salt will be slightly basic in nature. Then another example, if we are having a strong acid and strong base, for example HCl and NaOH, it will produce NaCl, a salt, but this salt will be neutral because it has formed from the strong acid and strong base. Now here I have given you a list of strong acid, strong base and weak base. You have to learn this. You just keep on revising this, so you will be able to learn that which one is strong acid and which one is weak acid, and then you will able to solve the questions easily. Now another topic is the chemicals which are obtained from common salt. So there are many chemicals which obtained from the common salt, but first let's understand what is common salt. So common salt is sodium chloride, NaCl. This is obtained from NaOH and HCl. Just we have done that NaCl is a salt, it has obtained from a base and acid. So Na is obtained from a base and Cl is obtained from an acid. So this is a strong acid and strong base. That is why NaCl is neutral in nature. This NaCl is present in the seawater. Seawater contains salts in it. So when this seawater is collected at one area and is set for an evaporation, the water is evaporated and the remain behind is all salt. But this salt is called rock salt, which is brown in color because it contains some impurities in it. And when it is refined, then it comes into a white powder which we receive in a packet form. This is a rock salt and this turns into white powder when it is been refined. This common salt has many applications. First of all, it is added to the food to add the taste, and secondly, it is used to manufacture many chemicals like sodium hydroxide. Yes, it is prepared from the sodium hydroxide, but still it itself prepares sodium hydroxide. Then baking soda, washing soda, bleaching powder and many other compounds are prepared from the common salt. Let's understand about sodium hydroxide, that how sodium hydroxide is prepared from the common salt. First of all, the sodium hydroxide is also known as caustic soda and its formula is NaOH, in which Na is a cation and OH is a anion. When electricity is passed through the aqueous solution of sodium hydroxide, which is also known as brine, this NaCl, when dissolved in the water, the aqueous solution of it is known as brine. So through this brine, when electricity is passed, then NaOH is produced as cathode, hydrogen is also produced as cathode, and chlorine is produced at anode. So how this happens? When NaCl is dissolved in water and electricity is passed through it, this NaCl is split into Na plus and Cl minus. and this H2O is split into H plus and Cl minus. And when electricity is passed through it, then they are having two electrodes. One is anode and the another one is cathode. So here you could see that this is the positive terminal of a battery. So this terminal is attached to this electrode. That means this one is anode. Anode means positive terminal, and this is connected with a negative terminal, this electrode. So this is our cathode. Cathode means negative terminal. So when NaCl is, when we have taken an aqueous solution of NaCl, so this NaCl splits into Na plus and Cl minus. So Cl minus will reach, because of a negative ion, it goes to the positive terminal. It been attracted towards the positive terminal. Similarly, the H2O splits into H plus ion and OH minus ion. So this H plus also get attracted towards the negative ion, negative electrode, that means cathode. So after reaching to the cathode, it forms hydrogen gas here, and when chloride ion reaches to here to the anode, it forms Cl2 gas, yani ki chlorine gas. Now we are left with Na plus and OH minus. Cl has formed chlorine gas and H has formed hydrogen gas. Now Na is left, and from here the OH is left. This NaOH together forms a compound which is known as sodium hydroxide. So we can see here that NaCl is forming ions, and these ions are moving to the opposite terminals. Like for example, we are watching the positive ions are moving to the cathode and the negative ions are moving to the anode and forming chlorine gas and hydrogen gas. Now we are left with Na plus and OH minus. This Na plus and OH minus will together make a bond and will be collected in the solution. So here this is a chlor-alkali process which is very important. So this process gives us many compound: chlorine gas, hydrogen gas and sodium hydroxide. Now let's understand the practical application of the products which we have got from the chlor-alkali process. So first of all, the chlorine gas which we have got from the anode, the chlorine is used to treat the water. Treat the water means it is used to clean the water. It is used as a disinfectant in the water to purify the water from the river water which we get in our taps for drinking purpose. So that water is treated first. The germs and impurities have been removed first. So this is done with the help of chlorine gas. Then similarly the swimming pool water is also cleaned by using a chlorine gas. It is also used to manufacture polyvinyl chloride pipes, disinfectants, chlorofluorocarbons and pesticides. Application of hydrogens are, it is used as a fuel and it is also used to manufacture many fertilizers like ammonia. Now the application of sodium hydroxide, it is majorly used for preparing soaps and detergent, and it is also used to prepare artificial fibers and in the paper industries. Now the next chemical which we get from the brine is baking soda. Its chemical name is sodium hydrogen carbonate and the formula is NaHCO3. How it is prepared? First we take a brine solution, and to this brine solution we pass the carbon dioxide gas and ammonia. By this reaction, ammonium chloride and sodium hydrogen carbonate as baking soda is obtained. This baking soda is a mild base which is used as an antacid. It is also used in the fire extinguishers, and when it is heated in cooking, then it produces sodium carbonate, water and carbon dioxide gas. This carbon dioxide gas is used to make bread and cakes soft and fluffy. When pinch of tartaric acid is added to the sodium hydrogen carbonate, means baking soda, then it turns to baking powder. It builds up a taste in the baking powder. in the baking soda, sorry, because baking soda is basic in nature, so it has some bitter taste. So we cannot add baking soda in large proportion in the food. So if we want to add baking soda somewhere in large proportion, then we use baking powder along with baking soda, because the tartaric acid which is present in the baking powder, this removes the bitterness of the baking soda. There are some other uses also of baking soda. It is used as a cleansing agent for our body, like for skin, for hairs, for our mouth, and also as a disinfectant. Now the another chemical which we get from the sodium chloride is washing soda. The sodium carbonate which has obtained from the baking soda, to this sodium carbonate when we add 10 molecules of water, then this sodium carbonate crystallizes to form washing soda. So what is the chemical name of a washing soda? Sodium carbonate decahydrate. This deca means 10 and hydrate means H2O. So its molecular formula is sodium carbonate Na2CO3 into 10 H2O. This washing soda is used for various purposes. It is used in soap and paper industries. It is used to manufacture borax. Borax is very important chemical in the industry to manufacture many other chemicals. It is also used as a cleansing agent for the domestic purposes, and it is also used for removing permanent hardness of water. The next compound is bleaching powder, which we get from the sodium chloride. How? The bleaching powder name is calcium oxychloride and the formula is CaOCl2. Calcium oxy means CaO and chloride Cl2. So calcium oxychloride means CaOCl2. Now it is prepared by calcium hydroxide and chlorine. This chlorine we have got from the chlor-alkali process, and this chlor-alkali process is when we mix the brine together. So that is why we are getting all these products from the NaCl. When these two compounds are mixed together, it forms calcium oxychloride, which is our bleaching powder, and water. This bleaching powder is used in the textile industries for bleaching the cotton. If we have any stain in our fiber, so that is removed by using the bleaching agent or bleaching powder. This bleaching powder is also used to bleach or to remove the color from the wood pulp in the paper industry. It is used as an oxidizing agent in the chemical industry and is also used as a disinfectant in drinking water. Then our last chemical is plaster of Paris, which is also known as POP. Its chemical name is calcium sulfate hemihydrate. Hemi means half and hydrate means H2O. So its formula is calcium sulfate dot half H2O. When we heat the gypsum at 373 Kelvin, 373 Kelvin means 100 degrees Celsius, it loses the water molecule and becomes plaster of Paris. So here it's the reaction, calcium sulfate into dihydrate 2H2O. This is a formula of gypsum. When we heat this compound to 100 degrees Celsius, then we get plaster of Paris. That means 1.5 molecule of water is removed and only half water molecule remain behind. Then this plaster of Paris is formed. If we add a little amount of water to this plaster of Paris, then it again forms a gypsum. That means when the plaster of Paris in a powder form and when we add water to it, then we apply the area where we want to set it, then this after setting it gives a gypsum to us. Then doctor uses this POP for supporting the fractured bones and for making toys, material for decoration, and for making the surface smooth. We use this POP. Now these are all chemicals which we obtain from the sodium chloride, or we called as brine solution. First we have got the caustic soda by the electrolysis process. Electrolysis means by passing electricity. When we have added carbon dioxide and ammonia to it, then we have got baking soda. When baking soda is heated, then 10 amount of water molecules is added to it, then we have got washing soda. If we directly add carbon dioxide, ammonia, heat, and then we give 10 molecules of water to it, then we directly obtain washing soda from the brine. And lastly, we have got the bleaching powder from the brine solution, because the Cl, the chlorine gas which we get from the brine solution, this chlorine gas is used to prepare bleaching powder. So this is the overview of this whole reaction, so that it will be easy for you to learn all these reactions. Now the last topic is water of crystallization. What is a water of crystallization? It is the fixed number of water present in any molecule, in any formula unit of salt. For example, this is a copper sulfate formula. In this 5H2O is a fixed number of water molecules. This fixed number of water molecules is our water of crystallization. In this washing soda also, we have seen that 10 H2O molecule was there in the formula. So this 10 water molecules are water of crystallization. In gypsum also we have seen that 2H2O was there in the formula. So this 2 is water of crystallization. In iron sulfate also, the iron sulfate, the green color which we get is because of this 7H2O. And in lastly, we have got from the plaster of Paris. Plaster of Paris also we have seen the half H2O was there. So this half H2O hemihydrate is our water of crystallization. Now what is the importance of this water of crystallization? By this fixed number, or by the molecules, by this H2O molecules, the powdered salt becomes a beautiful crystal, and it also get a characteristic color. For example, if we are having a copper sulfate 5H2O, this is also known as blue vitriol. This is having a very beautiful this color. When we heat this compound, then first of all this 5H2O molecules get removed out of it. Then the copper sulfate which left behind is of white colored powder. It's not having any crystal, and it's not having any color also. This happens for all of the compound which we are having the crystallization or the water of crystallization. So the beautiful color which we get, a very distinct color which we get, that is because of water of crystallization. And also the crystal nature which we get, that is because of this water of crystallization. That is why we call it as water of crystallization, because this water is only giving the crystal characteristic to it. So thank you for all students till now. Here this is the time of doing the questions. To recapitulate the concept, if you face any problem in the video, in the questions, then you can ask me in the comment section, and please do comment me that how much you are liking my videos.